Let's continue looking at our transformations that we can perform on some of our parent functions. Notice this time we're going to be doing vertical shrinks or stretches. So a vertical shrink would be if you had your graph sitting here like this maybe, and you squeezed it vertically. So that's smashing it down. A vertical stretch would be if you stretched it out. So you're pulling the points to where they get tall and skinny. Okay, shrink would be making it shorter, which when you vertically shrink it, it actually makes it look like it gets wider horizontally. Okay, we can also do horizontal shrinks or stretches. Horizontal shrink would be like if you squeezed it in horizontally, which will make it look like it gets skinny. Interestingly enough, squeezing it horizontally will make it look like you stretched it vertically. Okay, or a horizontal stretch would be if you pulled it out horizontally. Okay, all right. Vertical stretches and shrinks. Again, they use the letter A to represent this, and again, that means that A value is outside the X. So, for instance, maybe our original function was absolute value of X. If I put a 2 out in front of it, it's not in the bars with the X, it's out separate, that would be a vertical stretch, because if you multiply something by 2, it should get bigger. It should get twice as tall. We should stretch it out vertically. Okay? So if the number in front of your function here is bigger than 1, it is a stretch vertically. If the number you put is between 0 and 1, so like 1/2, 1/3, 0.4, 0.6, something like that, something between 0 and 1, then it will be a vertical shrink. It will squeeze it down vertically. Okay? Horizontal, remember that means that you're going to put your A value in with the X. It's in the bars. So maybe your original function was absolute value of X, and if I put a 2 in the bars with the X, something's going to happen horizontally. X-axis is sideways, so something will happen horizontally. X's lie. They always go the opposite direction that you would expect. So you would expect if you put a number bigger than 1, like 2, you would go, oh, I bet it's going to get bigger. But remember, X's lie, so that means it will actually shrink horizontally. It will actually get skinnier horizontally. And if you put a number between 0 and 1, like 1/2 or 0.7 or something in between 0 and 1, then it will be stretched horizontally. Okay? Remember, X's lie. Horizontal stuff is always backwards of what you would normally expect. Okay, so parent function here is y equals x squared. So our normal, furious 5, if you put in 0 for x, you would get 0. Put in 1, you get 1. Plug in 2, you get 4, because 2 squared is 4. You could do 3 or 4. I'm going to change that to -1 and -2. If I square -1, I get 1. If I square -2, I get 4. So my normal graph would look like this. This is regular old y equals x squared. Okay? Now notice what they put right here. They put a 1/4. This is not in parentheses with the x. Okay, this 1/4 is not in parentheses with the x. This 4 is not in parentheses with the x. We'll look at some in a minute that will be in parentheses with the x. Okay, so if it's in parentheses with the x, then that's something happening sideways along the x-axis. These 1/4 and 4 are not in parentheses with the x. They are not something sideways. They are something vertical. Okay. When the number is bigger than 1, like 4, it's a vertical stretch. We're pulling it taller. When the number is smaller than 1, like this 1/4, it's a vertical shrink. We're smashing it down. It's going to get shorter and skinnier. So this one is a vertical shrink. Okay. So we shrink it down. We make it smaller. We're going to take all these y values and divide them by 4. Okay, it's going to be 1/4 the size that it used to be. It's getting shrunk down. So 0 divided by 4 is 0. 1 divided by 4 is 1/4, or 0.25. 4 divided by 4 is 1. 1 divided by 4 is 1/4, or 0.25. 4 divided by 4 is 1. So the point that used to be at 0, 0 is still at 0, 0. The point that used to be at 1, 1 is now at 1.25. The point that used to be at 2, 4 right up here is now at 2, 1. The point that used to be at negative 1, 1 is now at negative 1, 1/4. The point that used to be at negative 2, 4 is now at negative 2, 1. So notice what happened to our picture. By vertically shrinking it, by squeezing it vertically, do you see how it smashed it down? It made it kind of open up and get wider. Okay? It's a vertical shrink. Now, what if we had a 4 in front? We have a 4 out in front. It's still vertical. It's not in parentheses with the X. It's still vertical. But it's going to stretch it vertically. Everything is going to get 4 times taller. So this is a vertical stretch. Okay, my original ordered pairs are the same. 0, 0, 0, 1, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Those are the same. But now, because we're stretching it vertically, it's going to get 4 times taller. I need to take these y values and multiply them by 4. Ooh, 4 times 4 is 16. That's a big stretch. So my point that used to be at 0, 0 is still at 0, 0. My point that used to be at 1, 1 is now at 1, 4. 2, 16 is way off the chart here. Negative 1, 4 is right there, and negative 2 way up here at 16. Notice how this graph has gotten very tall and skinny. We have taken that red one and pulled it tall and skinny. Okay, we stretched it out vertically. Okay. Let's look at another one. Here's a square root function. Okay. Now remember, square root of x. Okay. If I put 0 in there, square root of x would be 0. If I put in a 1, square root of 1 would be 1. Square root of 5 would be like 2.2 or something like that. Square root of 6 would be like 2.4. Those are kind of messy. How about I make that a 4? Square root of 4 would be 2. Okay, so 0, 0, 1, 1, 4, 2. There would be a couple decimals there. Okay. Oops. Okay. Hang on. What was square root of 5? Sorry. Square root of 5 is 2.2. Yeah, I don't really think I need those right there front now. Okay, so what happens though with this 5 in the radical with the x? Well, since it's in the radical with the x, it's going to be something horizontal. And normally you would think, oh, well, multiply by 5, that's going to stretch it out. That's going to make it bigger. But remember, the x's lie. The x's are always backwards. So in multiplying by 5, instead of stretching it, is really going to shrink it. Horizontal shrink. So what we want to do is we want to take all of our x's, and I'm going to ignore this y column over here. I'm going to take all my x's, instead of changing the y's, I'm going to change my x's, and I'm going to divide them by 5. So 0, because that's the opposite of multiplying by 5. Opposite of multiplying by 5 is divide by 5. X's are always backwards, so do the opposite thing. 0 divided by 5 is 0. 1 divided by 5 is 1/5, or 0.2. 4 divided by 5 is, let's see, 4 divided by 5 is 0.8, right? Okay, so notice what happens. 0, 0 is still there, but you go to 0.2 to get a 1 to come out for y. You go to 0.8 to get a 2 to come out for y. Notice what's happened to our graph. Do you see how we shrunk it horizontally? We squeezed it in. If I push this line in, it's going to look like it gets tall and skinny. Okay? All right. If I take those same 0, 0, 1, 1, let's ignore those two. Let's make this a 4. 4, 2. There's our original parent function. This time, what's happening? Our x's are being divided by 5. Well, Isn't that the same thing as multiplying by 1/5? Okay? So if we multiply by 1/5, that's a number less than 1. Instead of, you would think it would get smaller, but it's actually going to stretch it bigger. So we are going to multiply the x's by 5. 0 times 5 is 0. 1 times 5 is 5. 4 times 5 is 20. So 0, 0 will still be there. 1, 2, 3, 4, 5, but we go to 5, 1, and 20. We have to go way out here to 20 before we could go up to 2. So notice what happens there. This graph got stretched horizontally. It got pulled out. Okay? Okay, let's look at an example here. This one, we do not know what the equation is. We don't know. It looks sort of straight, like an absolute value maybe, but it's not a perfect V shape, and it's got an extra little tail over there. So we do not know what the original function was that produced this graph. Okay? But let's write down what the ordered pairs are. This point right here is -3, -1. This point is -1, +1. This point is 1, 2, 3, 4, -3. And this point is 6, 3. So these are the ordered pairs that they gave us. Now, their question to us is graph y equals f of 4x. So in other words, here's f of x right here. We do not know what the equation was that produced it, but some f of x function looks like this. So what happens when they put a 4 in there? Well, the 4 is with the x, so it's going to be something horizontal. And you would think that multiplying by 4 would stretch it out. Remember, x's lie. So instead of stretching it out, it's going to shrink it down. So this is going to be a horizontal shrink. Instead of multiplying all the x's by 4, we're going to divide all the x's by 4. So -3 divided by 4 is -3/4, or -0.75. -1 divided by 4 is -1/4, or -0.25. 4 divided by 4 is 1. 6 divided by 4 is 1.5, or 1.5. Okay? So the point that used to be a -3, 1, that's this point right here. Its new x value is -0.75. So -3/4, and the y stays at -1. The point that used to be at -1, 1, that's this point right here, is now at -1/4, -0.25, and a y value of 1. The point that used to be at 4, -3, that's this one right here, is now at 1, -3. And the point that used to be at 6, 3, that's this point, is now at 1.5, 3. And when I connect them in order, notice what happened to the graph. It is this same picture, but horizontally shrunken down. We squeezed it or pinched it horizontally until it was 1/4 as wide as it used to be. Okay? So our shortcut is we took all of those x's and we divided them by 4. Okay? What if we take those same ordered pairs, that same table, the original table that we had, -3, -1, -1, 1, 4, -3, 6, 3, the original ordered pairs right here, and now they want us to try to do this to it. Well, the 1/2 is in the parentheses with the x, so something has happened horizontally to our x's. X's lie. You would think it's going to be half the size. It's going to get shrunk down. 1/2 is small, but x's lie, so it's going to be stretched out. That reciprocal 1/2 is 2, so it's going to be stretched horizontally by a factor of 2. In other words, instead of being half the size, it's going to be twice the size. That reciprocal of 1/2 is 2. It's going to get 2 times bigger. Okay? We are changing the x's though. So instead of multiplying by half, we're going to multiply by 2. Multiply by that reciprocal. It's going to get twice as big. So -3 times 2 is -6. -1 times 2 is -2. 4 times 2 is 8. 6 times 2 is 12. So the point that used to be at -3, 1 is now at -6, -1. I have to kind of estimate that. negative 6, negative 1. The point that used to be at negative 1, 1 is now at negative 2, 1. Instead of 4, negative 3, it's at 8, negative 3. To estimate where that 8 would be at. And I don't even have room for 12, 3. It's off the paper here. But notice what happens. See how that graph stretched horizontally? It's twice as wide as it used to be. Instead of half the size, it's twice the size. So a shortcut would be to multiply each x coordinate by 2, and that's exactly what we did. Since we're doing multiplying and dividing here, let's look at the last type of transformation that we could see is a reflection or a flip. Okay? Reflections occur from using negatives. Okay? So if we put a negative out front, what's happening is we're flipping it over. We're changing all the y's from a positive number to a negative number, or from a negative number to a positive number. So your x-axis is sideways. So if you put a negative outside, you're doing something vertical. It's not with the x that's sideways, it's vertical. And if you flip it vertically, you're flipping over the x-axis. Now, I like to say it's a vertical flip or a vertical reflection because you're flipping it from top to bottom or bottom to top. But even though you're flipping vertically, you're going over the x-axis. Okay? If the negative is in the parentheses with the x, something is happening horizontally. You're changing something horizontally because you're changing something on the x's. You're flipping it horizontally, but that means it's flipping over the y-axis. So it's a horizontal flip, okay, flipping horizontally because it's with the x. Something is happening on the x-axis. But you're flipping horizontally, but that means it's going over the y-axis. Okay? All right, so here's a graph right here. We do not know what the function is that produced this graph. We can make a little table of values. It's going through 0, 0, 1, 1, 3, 3, and 4, 1. Okay? And they want us to draw this. They put the negative outside the x. It's not with the x. It's not changing our x's. It's changing our y's. So it's like there's a little negative 1 chilling there. So we're going to multiply all our y's by negative 1 times negative 1. 0 times negative 1 is 0. 1 times negative 1 is negative 1. 3 times negative 1 is negative 3. 1 times negative 1 is negative 1. So the point that used to be at 0 is still at 0, 0. The point that used to be at 1, 1 is now at 1, negative 1. The point that used to be at 3, 3 is now at 3, negative 3. And the point that used to be at 4, 1 is now at 4, negative 1. When I connect those points in order, notice what happened. Do you see how it took this picture and flipped it over, reflected it over the x-axis? Okay? The negative was not with the x. So the negative is changing something on the y's. We multiplied all the y's by negative 1. But the picture flipped over the x. If I take those same ordered pairs, 0, 0, 1, 1, 3, 3, and 4, 1. I take those same ordered pairs. This time the negative is with the x. That means we are doing something to the x's. We're going to multiply them by negative 1. 0 times negative 1 is 0. 1 times negative 1 is negative 1. 3 times negative 1 is negative 3. 4 times negative 1 is negative 4. The point that used to be at 0, 0 is still there. The point that used to be at 1, 1 is now at negative 1. Negative 1 is the x, 1 is the y. The point that used to be at 3, 3 now has an x of negative 3 and a y of 3. And our last point has an x of negative 4 and a y of 1. When I connect those points, notice what happened. See how it took this original picture and flipped it over the y-axis, reflected over the y, and that's how we got this. So the negative was with the x. It flipped horizontally, but that meant it went over the y-axis. Okay? All right, that's our last transformation. We talked about shifting up and down. We talked about shifting up and down or shifting sideways. We talked about stretching vertically or sideways. We talked about flipping vertically or sideways. Okay? And the next video will put all of that together.